Alright, so let's roll, people. Let's see what you remember. We're going to check over some types of reactions lab information from yesterday. Also, number 12 on problem set, because that was, I think, the most challenging of the bunch. This will give you a chance to keep redeeming yourself on, like, do I know polyatomics? Do I know that I have to crisscross? Do I know how to predict, or actually how to recognize a reaction as synthesis, decomp, single, double, combustion? And do I know the products that should be produced from that style of reaction? So in this first example right here, I'm already telling you it's synthesis, and I'm telling you what the product is. So what's the product? Aluminum oxide, right? So when it says, and so I'm phrasing them a little differently to give you a better idea of like how you can phrase them differently. So synthesis of aluminum oxide means to yield what? Formula. Al2O3. Aluminum's got 3+ charge, oxygen has a 2- charge. Why in that case though? Why are we getting these charges? Well, from the periodic table, but what are they doing to get those charges? Well, no, what is aluminum doing to get a 3+ charge? It's what? Giving up 3 electrons. Why does it give up 3 and not like 8 or 6 or 2 or 1? Okay, so it's closer to getting octet if it loses its 3 valence electrons. And why is oxygen getting a charge of 2? Right, it needs 2 to be octet. It has 6 valence electron, it needs 2 more. That's just a quick reminder that these are just coming out of our butt. They're actually informative from the periodic table. Okay, so that's aluminum oxide from its elements. So what am I telling you it's from? How do I write aluminum and oxygen? Al and O2. Beautiful, because diatomic oxygen is how you write oxygen when you have it as a singleton place. Balanced out, and you see the 2 aluminums. You see 1 over here, so naturally you probably put what here first? A 2, and then from here you see the 2 oxygens and the 3 oxygens, but you can't get 2 to equal 3, so what do you do with both of those? Multiply by the opposite of them, so that's kind of like least common multiple thing. So what am I putting here? And what am I putting in front over here? 2, and then you're like, oh no, there's 4 aluminums now, so I need to put a 4 here. It's a 4. Okay. So decomposition of aluminum carbonate. So I stuck with aluminum a lot here so that you can kind of keep that trend here. So aluminum carbonate, Syrian, what is this? So where does that 2 go?
Oh, it's charges 2, so it goes on aluminum, and then aluminum charges 2.
Beautiful. Okay, so that's your thought process as you're going. And so if you're still not comfortable, keep your charges separate and then separately crisscross them so you're not hitting the end before you're ready. So decomposition, is that it? Do I write anything else? So I write the yield symbol, right? Okay, and sometimes that's with heat, so you might put like a little triangle on top to say this requires some energy. And then you have to know carbonates always produce what product? Carbon dioxide is a gas. So a lot of times our decomps always make a gas. You just got to figure out which one it is. So I already know metal carbonates make carbon dioxide, CO2, and what is left? The metal, and oxygen, so a metal oxide. So what's the name of that metal oxide? Aluminum oxide. What's the formula for that? Right, we've already written that out today, so you kind of know Al2O3 from crisscrossing our charges, and then balance it out. What do I see that's not balanced? Oxygens and carbons. I'm not going to touch oxygen yet because they're in like 3 places, and once I start, I got to go back and forth quite a bit. So let's just start with carbon. So aluminum's already good, right? 2 and 2. So what do I need for carbon? A 3 where? In front of, so just say carbon dioxide, and that's going to be more helpful. So that's carbon dioxide, 3 oxygens, 3 carbons. How many oxygens total now on the product side? So there's 6 from 3 times 2, and then 3 from the oxygen there, so 9, and what's this? 9. So sometimes it naturally balances out, and if you cannot balance it, it's because you have a formula wrong. I guarantee it. So if like for some reason you put ALO just for aluminum oxide, it's because your formula is wrong. It's not because you like, I can't balance. Balancing is the easy part. So make sure that you're reflecting like, maybe it's not really balancing, maybe it's my formulas that I need to work on. All right, so combustion of butane. Now this was the one I spoke of in an intervention a little bit more, and we talked about the different ways that you named organic compounds with all those carbons involved. What were the sequence of prefixes that represented the carbons here? It started off with meth, which was like methane. Sorry, my notes to myself up here. So methane, and then ethane, propane, butane, and pentane. And from here on out, it's like normal prefixes: pent, hex, hep, octanon, deca, dodeca, and so forth. So I forget, like, somebody made up this little stupid prefix or acronym. So MEPB, many elephants play ball, or NEB. So whatever you want to say, many elephants play ball, or you can come up with another acronym to help you remember that order. You've heard of methane, ethane, propane, and butane, but you just may not remember which one's representing a certain number of carbons. So butane's the fourth one down. Guess how many carbons that is? 4 carbons. So you write C4, and then from our vast experience with bonding, we could draw out 4 carbons and then surround them with hydrogens. But that might take a little while, but we could do it. So if I had to, boom, 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 there's our 4 carbons. How many hydrogens needed to be surrounding those to give octet? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't take more than 30 seconds, really. You could do it. I'll also give you a little cheat sheet here in a second. So here's our carbon with 10 hydrogens. That's butane. That's what's like in a butane lighter. That's like a little big lighter you light. Okay, so combustion plus O2. Combustion means to you, make it react with oxygen diatomic gas. So that's going to be our initial reactants. And I told you guys always, anytime a hydrocarbon is burned or combusted, it always makes what 2 products? Carbon dioxide and water. And this is just like aerobic respiration in your body. But glucose is what our body burns for actual production of carbon dioxide, which, when does that happen in your body? Where does it go? Where does carbon dioxide go in your body? Out. Okay, yeah, you breathe it out, right? So you produce it, then you breathe it out, oxygen goes in. The water just nourishes your cells, and then it makes like 36 ATP. But our energy looks like fire and light, whereas biological energy is more like, ooh, ATP. Okay, so I always start with CHO, C, H, and then O, because O's are everywhere, so we always save the most complex for last. How many carbons do I need? 4 on the carbon dioxide, thank you. Speak my language. Okay, so carbon dioxide, we have 4. Hydrogens? So I have 10, so I need 5 on water. Okay, so then total oxygens over here. 4 times 2, so that's 8. Okay, and then 5. So 8 plus 5 is 13. What? How do I get 13 oxygens out of 2? Say again? Multiply them by each other. Okay, but if I do that, isn't it going to also change some? Like, how do I multiply these by individually by 2? I can't. So I actually have to double everything. Because what you want to do is you want to make 13 of these, right? So technically, and this isn't correct, you could put 13 over 2 to say 13 over 2 times 2, that's 13, correct? But you can't, like, have 7.5 oxygen molecules. Those don't exist. No halvesies here, okay? So this can't be here. So instead of putting 13 halves, you're just going to put straight up 13. So what did I do to the 13 half number? I multiplied it by 2. So I'm going to multiply this coefficient by 2, which would now be actually 2, because it's 1 times 2. This coefficient has to be multiplied by 2. It's going to be 8. And this coefficient has to be multiplied by 2, 10. So the coefficients are 2, 13, 8, 10. So the only ones that are really iffy like that is when you can't get a full number on your oxygen and you just basically double all the coefficients and it works itself out. Interesting? Okay. All right, fluorine and aluminum iodide. Fluorine, ready when you are. F2, good job. Making sure your diatomics are noted. Aluminum or iodide. ALI. Yeah, so aluminum's charges 3, iodine's charge 1, cross them out. And then before you begin here, I went ahead and told you synthesis, decomposition, combustion. What kind of reaction is this? How do you know it's single replacement? So 1 free element and a combo, and then what's going to have to switch here? Yes, the nominals. How do you know? Well, because the free element is a The free element is considered a nonmetal, right? It's a gas. So it's going to switch with the thing that's similar to itself, because that's the only thing that chemistry it's going to have to work with, because this is a positive charge for aluminum. Fluorine, when it forms an ion, will form what charge? -1. So it can't pair with another negative. It doesn't work like that in chemistry. So fluorine and iodine will switch places, but how will you know for sure this can happen? Based on the activity of the halogens. And how do you know that? Table. What's the order on the halogens? Who's top? Fluorine, chlorine, bromine, iodine. So yeah, fluorine's like, heck yeah, I'm switching with you. I'm the more active one. Switch. So who gets booted to the cold? How do I write iodine? I2, and then aluminum, fluoride, F, and there's a 3 because of the crisscrossing charges. And then balance. How do you balance it? I see aluminums are good, right? They're fine. But the iodines, I have 3 and 2, and fluorines I have 3 and 2, so what do you guys want to do? We'll put by each other. So this fluorine over here needs a what? A 3, because that one has a 3. But then how do I get this one fixed? Put a 2. So how many fluorines total? 6 total. 2 times 3, 2 times 3. So then I already see that I have 2 aluminums over here. What do I know I have to do? Put a 2 in front of the aluminum iodide, and so that gives me 6 iodines as well, and a 3 there. Okie dokie. You guys feel a little bit better with predictions? Possibly. Well, my goal is yes, and that's, that's every day my goal is to teach you something or reinforce your own knowledge. All right, so let's talk about type 2 reactions that you guys had. You guys are going to tell me your reactions that you have on A, B, C, and D, okay? Oh, dang it. I'll do some more combustion for you in a second. Never mind. All right, so go ahead before you talk to me. I know you're in different groups at your table. Take 1 minute to discuss anything you had a confusion or a piece of this that you did not know.
I have any questions on yeah, the only thing that was combustion, I just forgot that you have to add it to it.
Also, I can do this in
What's your MG2 plus MG2? Why is it MG2?
Hey guys, let's start with B. That apparently is the one that was a little iffy on the reactant side of things. So, who can tell me what sodium bicarbonate is? Go for it. I know it is baking soda, yes, and that's what I had on the bottles. I'm sorry. So go for it, Brandon. Sodium bicarbonate.
Na2.
Whoa, hold on. Sodium, Na. Done. Right? Let's just think about this first. Sodium is a 1+ charge. Bicarbonate. That's carbonate, right? But it's got a little bit of modification to it. Di in chemistry means 2. Bi means add a hydrogen. And it's a hydrogen ion you're adding actually to carbonate. So what's carbonate? CO3 charge? 2 minus, right. And this bi thing needs to add a hydrogen ion, so it's got a 1+ charge. Pull those together, what is it? H. It's actually not crisscrossing, it's weird. You actually have to take these and just push these together to make bicarbonate, because we're going to crisscross bicarbonate with sodium. I can't have already canceled the charges within bicarbonate itself. So push these together, you get HCO3 -1. Right, so now, if that helps you a little bit, think about it that way, but we've been through bicarbonate a couple times, so now sodium bicarbonate is formula what? NaH CO3. Charges, 1s, put parentheses there if it makes you happy, you're good there. All right, so you have your sodium bicarbonate. You put it in your test tube. So we're describing this for Lauren because she was in here. So we put it in our test tube. We held it over the Bunsen burner. And then what happened? Okay, so some people's turned yellow because they were burning it slightly, but that's besides the point. What else did you see? There was, oh, so was there anything else added to this? No, so we already know what kind of reaction it is just because of the single reactant. What kind is it? Well, what kind of reaction? We have 5 choices. Actually, we only have 4. It's decomposition. Okay, and then it was heated, so you put a little triangle there to say, haha, I remember how to show heated. And then you said moisture was forming. What's the moisture that's here? Had to have been water, right? Because many times you saw the water droplets condensing on the side of the test tube. What else did your, what other observations did you make? Frank? Okay, so we put this flaming splint inside the test tube mouth, and people kept putting it in, and it kept doing what? Extinguishing. You guys were like, it keeps going out. I was like, I know. So why does it keep going out? What gas could have been produced to extinguish a flame? CO2. Because what does oxygen do to a flame? It ignites. It's like keep burning, right? CO2. Guess what's in the fire extinguisher? CO2 is liquid, but when you decompress it. I was going to say decompressorize, but that's not a word. Decompress it, it will turn into gas. So CO2 had to have been a product because that's the only evidence of how does a flame get extinguished. So then your job is to figure out what that third product would be based on product balancing and the obvious choice that's left over. I hear sodium. The sodium is an alkali metal, which when with water does what? Do you guys remember this? Sodium metal, when it's in the presence of water, is explosive. Nothing exploded in your hand, right? I was waiting for my guy to go, explosion. No. So it can't be pure sodium, but it could be sodium with something else. Possibly oxygen. Okay, let's see if that works out. Well, how do you write sodium oxide? Okay, can you balance this? What do I need? Let's try it out. 2 in front of the what? Sodium bicarbonate. So the 2 here, that's going to settle the 2 sodiums. 2 sodiums. What else? That handles the 2 hydrogens as well, right? And there's 2. And 2 carbons. Okay. So to put 2 in front of carbon dioxide. Okay. How many oxygens over here? 6. How many over here? Say again? 6. 2 times 2 is 4, plus 1 plus 1. 6. Yay! Okay, that's your third product there. That's the only one that has actually 3 products. We haven't seen one like that before. Yeah?
Can you explain how you got the water again?
We actually observed the water. If you were looking at, and so that's why I really wanted you to make your observations yesterday, because if you saw the water, it should have been evident that it wasn't just there. It was because if anything, burning something would evaporate water off, but we were making water, which had to say, hey, I'm a product, right? Water's a product. The extinguishing of the little flame had represented the presence of carbon dioxide, and then that, like, the white turning white, you couldn't see, but sodium bicarbonate is a white powder, and so is sodium oxide. You couldn't have seen that. That's why I wanted to kind of derive it at the end by yourself. Okay? Does that help?
Yeah.
Okay. All right, guys, so let's do one more of these, the one that you were most confused with, A, B, or C. Any others? You guys have a comment? I heard A. You guys are dead to the world today. All right. So, what was the single reactant that you was an obvious choice for A? Magnesium, right? And there's magnesium metal, is a strip of metal, right? That single strip of metal put in the flame, and then it lit up like the sun. Okay, but what had to react with it, because it couldn't have reacted by itself because it's a singular metal, it can't decompose. So the presence of oxygen in the air possibly was there, and so then you made magnesium oxide, Mg, I hear Mg2, why MgO? Come on, Mg, and I'm not going to keep making crisscross charges, you guys got to know that, Mg2 plus O2 minus crisscross produce. And then, yeah, so at this point, this is not balanced, so go ahead and balance it. In front of, okay, Mg over here, and then a 2 on the magnesium oxide. So after you've written out your red right here, that's actually the correct formulas. Don't change your formulas, only add coefficients to balance out so you're not breaking the law. And then that right there produced That was produced in the presence of heat, so we put a triangle on top of the arrow as well to indicate heat was present. Okay? Yeah. Can you help me out with B?
It was, oh, copper sulfate.
Whoa, copper what?
Two.
Copper 2 sulfate. Okay, reacts with iron filings, yields. What kind of reaction is this? Single replacement, because you see that free element. It's going to have to replace who? Copper, which you saw the copper blue color. That was in the blue solution. It started to kind of dim down the color. It was muted. And at the bottom of your test tube, you saw this black powder that turned what color? Kind of a goldish, brownish copper color, huh? So guess what we made? Copper. You're an alchemist. You made iron switch places with copper, and you pooped out copper. Okay, you made copper, and so iron had to be with who? Sulfur or sulfate. So, and I told you yesterday, iron's most common charge was what? 3. So crisscross and tell me. Fe 2 SO 4 3. You guys can balance from there. Okay. All right, so let me pause on this. I really need to talk about some of those problem set ones you guys had some issues with, okay? So problem set 11 is out. You guys will make sure you finish your running to low on time, which is okay. I have a replacement reactions lab with you guys today, and there's some really, really good NIE examples that if we only get halfway through, I'm fine with that, but it's a good example of what the NIE actually means in real life. So take your problem set, switch with your neighbor. Everybody needs a different colored pen because I want to see the corrections that are being made so I can see where your struggles are. I'm going to check through probably about 5 of these. Switch your problem set right now with somebody. If you don't have a different colored pen, let me know. I'll give you a marker. Sorry, throwing things at people. Does anybody need a marker? I'm turning around. Sorry, hold on. In there. Markers? Sophie? Oh my gosh. I'm sorry. These stuff might be here random. Does anybody else need a marker? Here random. Anybody else? There's a left-handed zero. This is horrible. Anybody else? That was embarrassing. I'm sorry. I can throw with my left hand. All right, so on problem set 11, I'm going to go over about 5 of the number 12 examples. So you guys need to tell me from your own struggles. We're getting off that struggle bus. Tell me which ones I should do. Out of the A, B, and C, let's start with those. A, B, and C. Speak now for hold your peace. I'm starting with number 12, A, B, and C. Give me one of those. Speak to me. None of those? I know, but you should be able to tell me if you know how to do these. They're on the board. Yes, yes. Say again? C. Okay, sodium reacts with water. Sodium, Na. And you're trying to correct the person's paper so they can get feedback like I give feedback. I usually do a scratch, and then I'll make a note of what the correct answer should be. Give them quality feedback. Okay? So you should not have your own, nor should you have a pencil. You should have a marker so that I can see the common mistakes, because if not, I am not an informed citizen, and I cannot help you from there. Thank you. Okay, so sodium reacts with water. And I said that commonly you'll write water as HOH to really help you see what's happening. So if you look at it now, you should identify that as a single replacement reaction, because sodium is the free one. It's going to replace the thing that's kind of from the same charge as it has. So sodium and hydrogen can switch places. So sodium gets with hydroxide, and so that's our new combination. So who got booted out to the cold? Hydrogen, like this? No, diatomic, right. So then you need to go back and go, okay, I've got one hydroxide, 2 H's, 2 H's, balance that out there. So then that also means you have 2 hydroxides yet again. So then that's going to give me a 2 here to give me the balancing of hydroxide, and then I need a 2 on sodium. That should be your final answer. Thumbs up? Okay, how about, let me do before I move on, lithium plus oxygen. I know it's an easy one, but I know you guys forget to crisscross charges. So lithium plus oxygen yields lithium oxide. This is a synthesis example. Who has somebody with the lithium 2O? Yeah, Li2O. It means you crisscross charges. If they didn't, they just put LiO, put a big scratch through it, but CCC for crisscross charges. Okay, so then our lithium would be balanced by putting a 2 up here in the front. Nope, lies. 2 over here for oxygen, so I need a 4 in the front. Is that balanced? Yeah, okay. You guys like how I write my 2s to 4s? Okay, ethane. Oh, actually, no, I lies. How about D through F? You guys tell me which ones you guys want me to do. Start with D. Nitric acid. That means you have to know your process of naming acids. Nitric acid is nitrate, NO3. Acid in the front, H in the front, 1 plus 1 minus done. Calcium, CaOH, parentheses 2. If they don't put the parentheses, scratch it because it's not correct. This has to be a 2 on the outside of the parentheses. What kind of reaction is this? Double replacement. You see 2Z's and 2Z's. So the H is going to be bonding with the other anion, which is hydroxide. So that's going to make HOH. Ooh, what's that? Water. Okay, so I think it's really helpful to write that occasionally. And then positive calcium and negative nitrate get together to make calcium, nitrate, CaNO3, parentheses 2. Balanced out would be 2 and 2. All right, thumbs up if your person's good that far. Okay, I am going to work on NIEs a little bit later. This one should have gone to NIE as well because it was a double replacement that I asked for you guys to work with. So I'll go over that one after I go over the rest of the simple ones. Now, ethane. We may have had to look up from our notes what ethane was. What is ethane? CH6. So C2H6, that's 2 carbons with 6 hydrogens around it for octet for everybody. Combusts, so reacts with oxygen. Yields, what do all hydrocarbons and oxygen make? Always carbon dioxide and water. Always, 100% of the time. And then balance out the CHO. CHO, C goes first. So 2 on the carbon dioxide, and then, hold on, I can't go to oxygen yet. I gotta go C, then H, then O, because I think it makes life easy. 3 in front of the water, so that's 2 carbons, 6 hydrogens, so that's been taken care of. Now total oxygens over here? 7, so that's 4 plus the 3, that's 7. So I know I can't put 7 there. I can't put 7/2 there. Sorry, I can't put 7/2. So I want to go ahead and double all the coefficients now. I want to put 7/2 there, so what's 7/2 times 2? 7/2 times 2, so it's 3.5 times, what's 3.5 times 2?
7.
Just 7. Okay, so that's a 7. And I'm doubling them all. So this is a, and this is a 4, and this is a 6. It's not pretty, but it's right. Okay. All right, moving on. How about, we already did something similar to that today. G through I. Nothing? You guys okay? G, copper 2 reacts with silver nitrate. Copper 2, do I write the 2 plus on a singular element? No, you just write copper. It's just, this is just for you, so you know later on when you have to crisscross charges which copper style it is. So just write copper solid, and it reacts with silver nitrate. What's silver nitrate? NO3, and that's a 1 plus and a 1 minus. And then at that point, copper would have to, we'd have to look at copper and look at silver. Look on your activity series. I don't have it in front of me. So AG is where compared to copper? At the, so silver is lower.
Wait.
No. Who is higher? Copper. So who wants to react? Copper. So is copper the free one? Yes. So will it react? Yes. So it will scooch and move silver out of the way. So because copper is more active, you'll switch it with silver. So copper gets with nitrate, so it makes copper what nitrate? Copper 2 nitrate, so NO3 2, and then we precipitate out pure silver, black market material right here. Okay, so you guys will do that in a lab eventually. Make your own silver. Okay. Oh, and then balance would be 2 and 2. Okay, let's do a couple more. So I just did that for warm up actually, so you guys got that. You got feedback you need anyway. I just did butane, right? M, I'll do M. How about anything else? That's from our lab from yesterday. Basically, except the copper is reversed. Ooh, but the copper is reversed. Hold on. So, hold on. I know I'm going to do M. Let me start with M for a second. Nickel. How do you write nickel? Ni. How do you write oxygen? O2. And then nickel, ooh, so there's a common charge for every transition metal. Nickel commonly forms a 2+ charge. So I didn't tell you that. That's probably why you're like, what? So if nickel forms a 2+ commonly, then how do I write, what kind of reaction is this? Synthesis, element plus element. Synthesis, crisscross charges, what do you get? So nickel, name it? Nickel what? Don't you say di. That's only covalent. I just told you the most common charge is nickel. Nickel 2 oxide. You still have to say that, even if you're not writing it, because the 2 from oxygen, 2 from nickel will crisscross and reduce. But you will still, because it is a transition metal, you still say it in its name. Nickel 2 oxide, and then balanced. Okay, let's do O, calcium hydride reacts with water. Okay, so this one's a little interesting. I'm going to have you guys write water as HOH for your own purposes. So calcium hydride, what in the heck is that? Ca. H2. Calcium's a 2+, hydrogen has a 1-, crisscross. Hydrogen can form a 1-, it's not all that common though. Reacts with water. How do I want you to write water? HOH. It's so helpful. Okay, so if you had to describe the type of reaction this was, you see 2 things and 2 things. It has to be a double replacement. Use a pen like I've asked you guys. Thank you. If not, I have no idea what you're doing wrong. Calcium calcium hydride and water will do a double replacement because it's 2 and 2. So do that and tell me what the first product is. Calcium, OH. Whoa. Yes, where's the 2 coming from? Calcium's charge. You still crisscross charges every single time, right? Okay, so that's going to be calcium and hydroxide crisscross. That takes care of this and this. So then this H, which is a plus charge, and this one, which is a negative one, actually just scooch together to make hydrogen gas, H2. Because that, other than that, you can't really have H. You just write it as H2. So that's a weird one, but we can do a double replacement with that. So balanced out? No. What do I need? 2 in front of the water, right? HOH. Okay, I'm going to stop for now. I can come back to some more of these, but I want to make sure that we have a chance to look over our NIEs a little bit more, because that's what our lab is on today. So, I want those problem sets, so keep those on your desk for a moment. I'll come back and grab those. On the lab sheet I gave you yesterday, I put on homework to take your reactions that I gave you here. I'll give those back to the people. Yeah, they want to see some mistakes. It should be balanced. Oh, hold on. H2. Yeah, that should be balanced. Oh no, it's not balanced. Hold on, let me balance that in a second. Let me tell you guys about this. Yeah, I need to fix O's balancing, so hold on for that. So guys, here, we're going to take about 5 minutes or so first. I know that some of us are going to have already actually achieved NIEs on this, because I asked for you to start on the website last night. And over here, you can see that there's a data table. So on questions 1 through 7, you should have either a double or a single place reaction written down in molecular form, normal form. Then you'll consider solubility rules, and you'll write your NIEs, the net ionic equations, which is what we learned yesterday. So you should have your notes out for that, especially the one outside, which is like step. After you get the NIEs completed and you predict that yes, a reaction will happen, or no, nothing's going to happen, it's just liquid making liquid and liquid, you'll actually do the reaction. So I'm going to kind of stagger you. If you've done 1 through 3, like already done the reactions and written them out, and you're beautiful and perfect, then you go to the lab, and I'll tell you guys how to get started back there. If you have not done 1 through 3, you need to approach those now, doing your reactions and your NIEs. And then we'll kind of keep flowing from there, okay? So raise your hand if you've done 1 through 3. All right, then hightail it back to the lab. So you guys need to use your goggles. All the chemicals, there's like 12 bottles of chemicals per little bucket. So do not contaminate them, or I'll haunt you in your dreams, remember? So watch out pipettes every single time, because you don't know who's had the pipette before you. Thank you. All right, other than that, guys, you guys start away. You guys have those fields, right? Start with 1 through 3 right there. Go.
This would be
level replacement. So you know the NIE rules? Start with that. But if all of them come out to aqueous, then there's no, and that means there's no reaction.
When you ionize them, do you keep the subscripts?
No, the subscripts are describing how many of them you have, so that would be like a coefficient. So if you have Na2, SO4, something like that, you'll see I have 2 sodium ions.
So if I have like BaCO2, I would have Ba plus 2
Ba2 plus 2 Cl minus.
Just making sure we're clear.
And I'm balancing those. Oh, I just need a 2.
I just need a 2 over here. Because after that, you had 2 H's and 2 H's, so that's 4 H's. So just put a 2 over there, and that fixes it. Hurry, I'm coming. Promise.
Oh yeah. That's not up to you when you write it, but you know your record. Or net or blue? Is it first column or last column? Yeah, don't talk about blue. I talk about the molecular picture or not? Except you have to balance it because there's 2 in it. So you have to just balance it. You just have to add a 2 for that.
We just have to do it.
So are you guys using your little step-by-step process for your chemistry formula? You have your double replacement, you do your solubility, you'll ionize the lead based on from there.
They're not the same. See, this is copper solid. This is not copper solid. This is copper solid. So that would not near it, and they're not the same. So there would be a reaction. Yes. Okay. Yes. So first story, this is a solid. Alright, we want to transition it to
Guys, make sure you have your charges. If it's a net ionic, it has a charge. Even in these, even the bottom of them.
Oh, I understand.
Because Bradley, I'm not trying to not support you, but if I teach you how to fish, you'll know how to fish forever, versus give you a fish. So.
Do you have all three of the first ones to give yes? Alright, so, yeah, you're trying to get the steps.
I mean, I kind of get the step, but then I don't know how I should write it.
How you should write it?
Yeah.
Yeah. Substitute.
That's what I was thinking, because I couldn't figure it out.
Yeah, but then I feel like, well, I'm talking about the final answer.
Yeah, so for one, being 02 was BA2, so U was BA, so was 2
Cross out. Wait, so that's your first. That's your net?
No, this is my first exam.
Okay, so you got anything they're gonna be solid. So that's the determine each one soluble. And if it's not, then that's like the
And if it's like a compound, I was always 4 rights, right?
no, you start looking at the convert, it'll be chloride. So you're looking for chloride on the sheet.
Okay, so all 4 rights. So that shows me that this would be 8. So far, oh, also. Okay, now okay, this one will be the subject. Which one? On the barium sulfate.
Oh, yeah, so forth. Okay. Yeah.
And after that, so I'll just bring these down. You bring these down.
Yeah.
And like, it's up to,
Yeah. So you break it up.
oh, so BA
Plus. And if you have a substrate, bring it as you make it cool.
and then what do we BA plus plus? 2.
BA is 2 plus.
It is? I thought oh, you're right. And then plus CC. Negative. Wait, so we put the charge?
Don't break up the precipitate.
So I can have this SO4.
So, yeah, sulfate is
Is that 2?
Yeah.
Get it all cancel out.
No, don't break up the precipitate. I got.
Guys, thank you for working with each other. You guys are each other's best help when I'm in the lab.
And so sodium and vortex.
Yeah.
And for your final equation, do you keep the charges on?
The net 2OH minus plus D2 plus yields DU2 with the OH.
Yeah, yeah. But you do balance it. But with one, you don't have
It's just not a done. Guys in the back, if you are moving on to step 5 and 6 and so forth, I would say the copper is right here, copper color is over here, the aluminum is here, and the copper fluoride have one container of each.
Yeah, so if you have like one substance, you have to put that in class.
Yeah. Yeah. And then after that,
My sequel you are going to be number 6. Go to me to number 7 for me. Okay. Number 7 just and then I'm going those of you who may want to step 7, I have one thing of copper 2 fluoride, so come and grab 14 of it and bring that. I only have 2 ammonium chloride if you need that.
Oh yeah, because when you told me that, okay, I think that's true. What did he? I don't think he said. Well, no. Oh, it's I agree. Okay, I think.
Guys, if you're still in the front, keep going through your NIEs. Go to number 4.
I recall. Okay, iron hydroxide.
Alright guys, finish your last reaction you're doing in about we're gonna clean up.
Wait, what's this? All of them yeah, it's the same as the office system. It's like every one of the are not equals, but it's that
Alright guys, clean up your lab stations. We're gonna complete up at the front. We need to go ahead and drop your precipitation. Yeah, get you the little teenage. All bottles and are washed out. If you do not get to the lab, you still owe me NIEs because the process of learning NIEs is like it's a process.
Like, which one is your
Alright guys in the back, please come on back up here. Thanks for being awesome today. We did a lot of review. I need a couple things from you before you go, so don't pack up all the way. What I need from you are problem set 11 is going to go in the box. Okay? I specifically need that. Who's 100% done with their types of reaction lab? The little questions on the bottom and everything. If your types of reaction lab is done, then types of reactions will go in the box. If not, I'm expecting that is done tomorrow. So problem set 11 in the box, types of reactions lab in the box. Finish, if you've not finished all of the 7 NIEs on the lab sheet, you need to finish those up, even if you didn't get to do the lab, okay? Who's mostly done? People in the lab, you guys were wonderful. You did a great job without my supervision.
Would you like me to turn it in? Because we did all of it except 6.
Yes. So that is not done. That's already done.
So if you've not finished Sex Reactions Lab, you need to finish that. If you've not done the NIEs, you need to finish those up as well. We leave in about a minute, guys, so go ahead and put those in the box with the rest of the information done. It's just the way it looks. It looks kind of lumpy. So toss that 11s in the box. Give me a yeah.
Yeah.
Hide your hands in the box. Yeah. Tomorrow, homework is reading at 12. And I will give you guys your quest back tomorrow. I thought I'm having one today.
Would you like the deadly marker back?
On my finger, and I accidentally stabbed my fingers. Woo! I didn't have anything done. Why are there so many markers? Here, I'll just give you my number because I don't want to snap. Stop while I want you to get it. Okay. I think I videoed the entire class. Yep.